tank contains 50 liters of oil at time t equals 4 hours. Oil is being pumped into the tank at a rate R of t, where R of t is measured in liters per hour, and t is measured in hours. Selected values of RT are given in the table above. Using a right-Riemann sum with 3 subintervals and data from the table, what is the approximation of the number of liters of oil that are in the tank at t equals 15 hours? So we have this table that shows the hours and the rate at which oil is being added into the tank. And they want us to use a right-Riemann sum to calculate what is the approximation of the number of liters of oil that are in the tank at t equals 15 hours. So to show what a right-Riemann sum would look like, let's quickly draw a little bar chart of what's going on. So here, let me redraw these axes. So on the x-axis, we'll have the time, and on the right axis, we'll have the rate at which oil is being added to the tank. And we have 4 data points from 4, 7, 12, 15 hours. So at 4 hours, the value of R of t is 6.5. Then at 7 hours, the value of R of t is 6.2. And then at 12, it is 5.9. And then at 15, it is 5.6. So what a right-Riemann sum calculates is the area under this curve that connects these points. It'll be some kind of a downward sloping curve. And we split the area under that curve into bars or rectangles. And we use the rightmost point of each interval. In this case, the rightmost point as the height of each rectangle, and the width of each rectangle to be the distance between each x value. So adding up the area of all these rectangles will give us the area, an approximation for the area under this curve. And the reason we want the area under this curve is because in this case, the area under this curve is the integral of the rate of change of the rate of oil being added into the tank. And the integral of that from time t equals 4 to t equals 15 is the amount of oil that is added into the tank. In the same way that the integral of the velocity from some time t1 to t2 gives us the position function and the distance, the displacement from t1 to t2. And in this case, we have this rate, which is the liters per hour. And in this case, taking the integral from time t equals 4 to t equals 15 is finding the area under this curve. And the area under this curve will be the total amount of liters added from the first time interval to the second. So we can use a right-Riemann sum to approximate this area under the curve. And the question asked us to use 3 subintervals. So that means we'll use the interval from 4 to 7, from 7 to 2, and from 12 to 15. So our first interval, we're going to use the rightmost y value as the height of our rectangle. So in this case, it's going to be 6.2. And we're going to multiply that with the width of the rectangle. In this case, from 4 to 7 is 3. Then we're going to add to that the area of the next rectangle. We're going to be using 1, 2, 3. We don't know what the time interval to the left of 4 was, and they told us to use 3 subintervals, so we're going from 4 to 7. So the first rectangle is going to be from 4 to 7 here. So this is actually going to be the first rectangle. And in this way, we also use 3 subintervals. So 6.2 times 3, because 4 to 7, that's the difference of 3, is the area of our first rectangle. And then the second rectangle, we'll use 5.9 as the height. And then multiply that with the width of this rectangle. So 5.9 is the height, since that is the value on the y-axis here. And so the width of this rectangle is just the difference in the x values from 7 to 12. So 7 to 12, that's a difference of 5. And then for the last rectangle, the third rectangle here, our height, we're going to use 5.6 and multiply that with the width, which is 3. And the reason we used 6.2, 5.9, and 5.6 as the heights of our rectangles because they told us to use a right Riemann sum. If we were using a left Riemann sum, we would use the values at the left side of the rectangles instead. So instead of starting at 6.2, we would have started at a height of 6.5 and then used 6.2 and then used 5.9 as the heights. But in this case, they told us to use a right Riemann sum. So we can multiply all these together. So 6.2 times 3, that's 18.6. 5.9 times 5, so 5 times 5 is 25, and then 0.9 times 5 is 4.5, and then 25 plus 4.5 is 29.5, and then 5.6 times 3, so 5 times 3 is 15, and then we add to that 3 times 0.6, 0.6 times 3 is 1.8, so we'll get 16.8. Now we can just add all these together. So 0.6 plus 0.5 is 0.11, and then adding 0.8 gives us 0.6 plus 0.5 is 1.1, sorry, and then adding 0.8 gives us 1.9. So we'll have to add this decimal value at the end, and then 18 plus 29, that's equal to 47, and then 47 plus 16, that's equal to 63. So the total area under this curve is 64.9. The whole numbers added with the decimals comes 64.9. So that means the total area in this curve from 4 to 15 using the right Riemann sum is 64.9 liters. So this is how many liters were added to the tank. But we know that the tank initially started at 50 liters at times t equals 4. So to find the total number of liters of oil in the tank after adding oil from t equals 4 to t equals 15, we would have to add those two together. So 64.9 plus 50 is equal to 114.9. And that's equal to answer choice C.